going to discuss the theories on acid, how it was defined an acid. Definition of acid according to Lewis. Anybody? Lewis' definition of acid. So that what word? Okay.
Lewis defined acid as an electron paired
Acid.
electron paired
Electron.
paired
Donator. No. Acid electron pair acceptor. Substance that accepts pair of electron are referred to as an acid. Then how about the definition of acid according to Brusselori? Brusselori definition of acid. Anybody? It shows that what we are taught you don't read. Please endeavor to. Okay.
Acid are substances that donate proton.
Substance that donate proton. Yes. You can say acid are proton donors. Then what about the definition of acid based on Arrhenius theory? Arrhenius definition of acid. Who is going to give us that? Arrhenius definition of acid. Yes, anybody? That is the most common definition of acid. A substance that produces on hydrogen ion when dissolved in aqueous solution. Then we also define the acid based on their strength. We say we have the weak acid, then we have a strong acid. What is different between a weak acid and a strong acid? Or when is an acid said to be weak and when is said to be strong? When acid is partially ionized in water, it's referred to as weak acid. But when it's dissociated completely, we refer to it as a strong acid. We also discuss the dilute acid and the concentrated acid. And that depends on the volume of acid to that of water. When acid, we have a large volume of acid, a small amount of acid, what we have is a dilute acid. But when you have a large amount of acid, a few amount of water, we have a concentrated. So to give an example of those ones there, then we're able to look at preparation of acids. How do you prepare acid in laboratory? How do you prepare acid? What are the methods of preparation of acid? Then I give you three. Can you remind us of those methods? Yes. Preparation from acid anhydride. And what do you say acid anhydride are? Outside of non-metals. And what happened to them? How do they become what? Acid. When they dissolve in water, they produce acid. We give example of oxide like CO2, nitrogen 4 oxide, sulfur 6 oxide, then sulfur 4 oxide. All these ones are acid anhydride. And when each of these dissolve in water, they produce corresponding acid. That is one method. Apart from preparation from acid anhydride, what other method is used or was used to produce an acid? As we discussed last week. Direct combination of the constituent elements. Then we have acid like hydrochloric acid, hydrochloric acid, and hydrofluoric acid will be prepared by combining their constituents. We give example of hydrogen chloride, and when you have hydrogen combined with chlorine, what you have is the hydrogen chloride. And it is when this one dissolves in water, what you have is the hydrochloric acid. Then we can also use acid to produce less volatile acid. For example, I think we use the sodium chloride reacting with concentrated tetrolysis. When it is heated, there will be production of hydrogen chloride. You know, we are using an acid which is stronger to produce a less stronger acid. So we have Na2SO4. So those are the ways by which acid can be produced. And we also look at the properties of our acid, both the physical properties and the chemical properties of acid. Can you give one physical property and one chemical property before we move on? Physical property of an acid? Salicylate. One chemical properties? It turns blue into spiral red. Then today we are going to look at the bases. Now we are going to look at the theory, 3 theories, just like we look at when we discuss an acid. So we are going to look at theories of arenos based on acid and on base. So let's look at arenos theory. So arenos theory defines base as a substance that produces a hydroxyl or hydroxide ion when dissolved in aqueous solution. So we are talking of it produces hydroxyl ion in aqueous solution. So that is how Arenos gave the definition of a base, a substance that dissolves in aqueous solution to produce hydroxide ion is referred to as a base. Mostly when you have an acid and a base is usually oxide of metal or hydroxide of metals. Usually bases are oxide or hydroxide of metals. We look at an example of CaO, Na2O, NaOH, CaOH into 2, ZNO or Z hydroxide A. All these ones they are referred to as bases. So that means a base could either be hydroxide of a metal or oxide of a metal. But the definition given by Arenos defines a base as a substance that produces hydroxide ion when dissolved in water. 2. Let's look at Brewster-Lowry theory. Brewster-Lowry. How did Lowry explain a base? A base is a substance that accepts proton. A substance that accepts proton is referred to as a base. You can see when you have an acid, Brewster-Lowry defines an acid as a substance that donates proton. That means if acid donates proton, what happens to base? Base will accept proton. Then the last one there is Brewster-Lowry, Lewis theory. Lewis defined a base as a substance that donates pair of electrons. Substance that what? Donates pair of electrons. So a substance that donates pair of electrons. Substance that donates electron pair we refer to as a base. Now let me give you this thing and let's see what if I have H2O plus hydrogen ion, and we have look at this equation. What can you say about this equation? What can you say about this equation? Which one of the substance there is an acid? Then which one is a base? Yes? Hydrogen ion is an acid. Water is? Why is hydrogen ion an acid? Because it's donating electron. Do you have electron here? When you have hydrogen ion, does it even possess any electron here? When you have hydrogen ion, it shows that hydrogen has nothing, and the atom shell, it has no electron. Is that okay? That means this one is going to accept pair of electron because it has no electron. When you draw the structure of water molecule, there are no pair of electron in the water molecule. Let's look at water molecule, for example. I have this is oxygen atom, we have this one. There's going to be one pair here. So we are going to have lone pair of electron here. Do you still remember the bond formation, chemical bonding? This is water molecule. In water molecule, there are two lone pair of electron and there are two bond pair of electron. Forgotten? So this one is bond pair. That means this electron, one is from hydrogen, the other one is from oxygen. Then here, one electron from hydrogen, the other one from oxygen. So we call it a bond pair. These two electrons here now, they are from what? Oxygen. So they are referred to as what? Lone pair of electrons. Are we together? This hydrogen here has no electron. What will it do? It will accept the electron from oxygen. Therefore, the water molecule here, which has oxygen, will be the one that donates pair of electron. Which one is getting the electron? Is accepting electron? Proton. Now, according to the Lewis now, which one will not be an acid? Which one will be a base? Yes? How do we define Lewis base? Substance that donates pair of electron. Which of these substances is donating pair of electron? Water molecule. So this is going to be what? A base. This one is one that is what? Accepting it. This is going to be what? An acid. I hope that is clear enough. That means when the common definition you have in acid as an acid is a substance that produces hydrogen ion when dissolved in water. Most time when the reaction occurs, you may not see it that way. We have identified acid and base, but we are not saying that this one is producing hydrogen ion and this one is producing hydrogen ion. So all the three theories should be understood on the acid: the Lewis theory, the Bruce-Lewis, and the English. Are we together? Now, when we say base, we have said that bases are usually oxides of metal or hydroxide of metal. So when you have a soluble basis, the soluble bases are referred to as alkalis. So when we talk of alkalis, we are talking of those bases that are soluble. So alkalis are soluble bases. That means not all bases are soluble in water. Those soluble bases are referred to as what? Alkalis. So you can say all alkalis are bases, but not all bases are alkalis. Do you get that concept? Yes. When we say alkalis, we will refer to as what? Those soluble bases. We can refer to as alkalis as what? As bases. But we cannot call all the bases what? Alkalis. Copper oxide will not dissolve in water. This is a base. Sodium oxide will dissolve in water. So, and when dissolved in water, what you have what? Sodium hydroxide. So we can refer to as sodium hydroxide as what? As alkalis. Very soluble base. Sodium hydroxide, potassium hydroxide. They are referred to as what? Alkalis. Because they are soluble bases. Are we together? Now, so also we have a strong alkalis, we have a weak alkalis. When a base ionizes completely in water, it's referred as what? A strong base. But when it partially ionizes in water, it's referred as what? A weak base. That is so usually strong bases are referred to as what? The alkalis. Now, how do we prepare bases? Preparation of bases. Preparation of bases. Has anybody tried one method of preparing the base? How do we prepare base? Combustion of active metals. Or combustion of active metals in oxygen. So, number one, we can prepare base by burning active metals in oxygen. For example, number one, reaction, let's say reaction of active metals in oxygen. For example, we have sodium. If sodium is burned in oxygen, what you have is a sodium oxide. Sodium oxide is an example of a base. And how can we get that? When you burn oxygen and we burn sodium in oxygen, you have sodium oxide. That is one method. You can as well burn potassium in oxygen to have potassium oxide. So is this reaction balanced? So I think it's balanced that way. So that is sodium oxide. That is one method. So reaction of active metals with oxygen. We can as well dissolve by dissolving sodium oxide or active oxide of active metal in water. It also gives us what? A base. So that's what we can say. Dissolving oxide of active metals in water. If we have Na2O, who can tell us what happens when sodium oxide dissolves in water? What do I call sodium hydroxide? But sodium hydroxide is also what? A base. We have said a base could either be oxide of metal or hydroxide of metal. Now balance this equation for me. Anybody? 2 as sodium hydroxide. That's all. So that is one method. Anybody try another method of getting or preparing a base? Want to try? Is ammonia or a base or an acid? Ammonia is a base or an acid? It's a base. How do you prepare ammonia? By direct combination. Yes, you can get it when you have nitrogen react with hydrogen ratio 1 to 3 at high temperature and under pressure. But apart from that, is in the industry. We are talking of laboratory preparation. How do you prepare ammonia in laboratory? Yes? Ammonium chloride, CaOH. Or you can even use sodium hydroxide by using alkalis against, or when you eat a mixture of chloride salt and base, what you get is ammonia. You may use ammonium chloride to sodium hydroxide. Instead of sodium hydroxide, you can as well use calcium hydroxide. So what you are going to get will be a salt will be formed. So that will be sodium chloride. What will form again? you have water and the gas, which is what? Ammonia. That's another method. You can also get a base produced by heating the mixture of ammonium salt against what? Alkali. And in this case, the alkali we use is what? Sodium hydroxide. By the time our next practical, we are going to do salt analysis. One of the ways of detecting or confirming or getting ammonia from ammonium salt is by adding sodium hydroxide to the solution of a salt, and you heat. When the mixture is heated, there will be evolution of a gas, effervescence will occur, and a colorless gas with a choking smell will what? Evolve. And that gas will turn a wet red litmus paper blue, showing that the gas is basic or alkaline. And usually when you have the characteristics of ammonia has what? A choking smell. It smells like what? So that is another method of preparing the base. Now, what are the physical properties of base? Physical properties. Physical properties. They are what? They are soapy to touch, yes. They are slippery, and what? They have a slippery, they have a soapy to touch, and they are slippery, yes. They have a bitter taste, so yes, bitter taste. Yes, concentrated alkalis is caustic or corrosive. Most time when you use soap that is having high concentration of alkalis, what happens to your hand at the end of the day? You sure that your hands will be peeling. It's because you have used so much. That soap contains too much caustic soda, which is a base. Now, chemical properties now. Chemical properties. Chemical properties number one. Chemical properties number one. It turns to bases turn red litmus paper blue. Just like an acetone blue litmus paper red. So based on red litmus paper blue. What are the other reactions? A base reacts with acid to form salt and water. And what type of reaction is that? So you can see HCl plus KOH will give us KCl plus H2O. So we have an acid, we have a base, and what we have is salt and water. Do you have any other reaction of base? A reaction that we wrote here can be a reaction. It can be reaction of chemical reaction of a base. Notice a base. A base. When a base reacts or is heated with ammonium salt, it liberates ammonia gas, just like ammonia gas is produced here. So you can say when base reacts with ammonium salt, it liberates ammonia gas. Base reacts with ammonium salt to liberate ammonia gas. I don't want to use this reaction again. I want to use another one. So let us use ammonium nitrate. If ammonium nitrate is used, and we use potassium hydroxide as our base. What will be the product of this reaction? Considering the reaction that I wrote here. What's going to be the product of the reaction there? We are going to have potassium tribromide, that is the salt produced, yes. We are going to have water, and there will be what? Evolution of ammonia gas. Is Is the reaction balanced? That's another chemical properties of the base. You can as well use calcium hydroxide. When calcium hydroxide is used there, it's going to precipitate out ammonia gas. So whenever a base or alkalis is added to ammonium salt and this mixture is heated, it is not going to be immediately that you add the salt and the base together that the gas will be born. There must be what? Heat is required. And when you heat, there will be effervescence. Effervescence means what? Now what are the uses of base? Each of these substances called base has its own peculiar use. Sodium hydroxide is used in the production of soap, glass, and etc. So let us look at uses of bases. Number one, sodium hydroxide is used in the manufacture of soap and glass. You know, you can also use potassium hydroxide in the production of soap.
Yes.
What happens if you use potassium hydroxide to produce soap and sodium hydroxide is used to produce soap? What difference will be? What type of soap? Or what ought to be the difference in the soap that soap produce if you use each of the substances that I've mentioned? Yes. With sodium we have hard soap. Then with potassium hydroxide we have soft soap. That is good. So, which other one? Magnesium hydroxide. What is the use of magnesium hydroxide? What does it use? It is used as laxative. When you have problem, that is when you have problem with your stomach. You see, you go and use what do you call this white thing? No POP. Mismark. No, mismark contains what? Magnesium hydroxide. So it is used as a laxative. It is used as that's magnesium hydroxide. Calcium oxide is used to reduce soil acidity. That's the process we call what? Liming. When the soil is too acidic, you want to reduce its acidity, what do? You can add this calcium oxide or calcium hydroxide. And that process is called liming. So at least that one is okay like that. So now let us now look at the measurement of acidity and alkalinity. Measurement of acidity and alkalinity. Now, if you are given a solution, I want to know, is the solution acidic, neutral, or basic, or alkaline? What are the substances that can be used to test for it? How do you determine the acidity or alkalinity of a substance? You can use what? pH meter or pH scale. So we have pH scale or meter. Or you can make use of what? You can make use of indicators. So that to determine the acidity or alkalinity of a substance. So now we make use of the pH scale or pH meter, or we make use of an indicator. Then what do we call pH? What is pH scale? The pH scale is a scale that ranges from 0 to 14 to 0 now. You are having what? So the acidity increases as you are moving from 7 towards 0. But alkalinity increasing from 7 towards 14. So let us say this is increasing acidity, and this is increasing alkalinity. Usually you can also use a pH scale and pH meter. Usually it's just a digital machine like this. It has electrode. Once you dip the electrode into the solution, you can read the pH of the solution on the meter. Very simple. You know when you have from 0 to less than 7, you know it is what? Acidic. And when it reaches 7, you know this thing is what? Neutral. I mean later it's moving towards 7.1, 7.2, 7.2, let's say 8, 9, you know you are moving towards the alkalinity. But you can also calculate. If you know the concentration of the solution, you can determine the pH of such solution. How do we do that? pH of the solution is given, call this one, pH means power of hydrogen ion, and is defined as the negative logarithm of hydrogen ion concentration to base of 10. How are you looking like this one? I don't like the way you are looking at. If you are not, this one is supposed to be a revision for you. Supposed to be a revision for you. Supposed to be a revision class and this one for you. So pH is given as what? pH of a solution is equal to minus log hydrogen ion concentration. That is to the base of 10. So you can say the pH of a solution. You have to define what the pH. A pH is the negative logarithm of what? Hydrogen ion concentration to base what? 10. Though pH itself means what? Just addition for what? Power of hydrogen ion. And for us to determine that, that means if the concentration of the hydrogen ion is known for a given solution, we can determine the pH of such solution. All you need to use is get the formula. You can as well determine the pH of a solution. That means the pH of a solution can be determined as well as a pH. So the pOH now, or say you can say the pH can be written as log 1 over hydrogen ion. You know this is mathematics now. This and this is the same. So now you use negative logarithm of this one. Or you can say pH is equal to log of reciprocal of hydrogen ion concentration. Am I complicating? You are not responding well. You have not eaten this afternoon. Maybe we serve. And we shortly ask and it shall be given. Now you ask. Should be your pastor. Don't worry. Come in. I will call them at the restaurant to prepare for this. Yes. That is it. We can also determine the pOH of the solution. pOH of the solution is equal to minus log hydroxyl ion concentration. Are you getting my point? So as you can determine the pH of the solution, that is power of hydrogen ion concentration, you can also determine the power of hydroxyl ion concentration. That's going to be minus log hydroxyl ion concentration. Or we can say pH. pO is equal to log 1 over hydroxide ion concentration. All this formula will be useful for our calculation because we are going to do calculation shortly. Look at the scale that I've written there. The scale, pH scale ranges from 0 to 14. That means if you know the pH of a given solution, you can as well determine the pH of that same solution, because a solution cannot have more than pH of 14. So here we can say the pH of the solution plus the pOH of the solution will give us what? 14. It means if a solution is having a pH of 2, its pOH is going to be what? 12. And the pH of the solution is 1. The pH is going to be what? Is that okay?
Yes, sir.
Then again, we can find hydrogen ion concentration of a solution multiplied by the hydroxyl ion concentration of that solution is equal to 10 raised to the power minus 14. Hydrogen ion concentration times the hydroxyl ion concentration is equal to 10 raised to the power minus 14. We may be given the concentration, hydrogen ion concentration of a solution, then we have to find the hydroxyl ion concentration of that same solution. So this one is applicable. So hydrogen ion concentration multiplied by hydroxyl ion concentration. This symbol in chemistry represents concentration. On pH and pOH. So let us discuss the second method of determining the acidity or alkalinity in a solution. We have an indicator. What are indicators? What are indicators? Indicators are weak acid or bases. They are weak acid or bases which change color depend on the pH of the solution. Weak acid or bases which change colors depending on the pH of the solution. That means the color of a particular indicator differ from, the particular medium differ from it in another medium. So we are going to look at two common acid-base titration indicator here. So let us look at the indicator like methyl orange. Yes, we have methyl orange. Let's look at indicator. So we have methyl orange. So we are going to look at methyl orange. We are going to look at phenolphthalein. No, that is the truth. That one is not. We are going to look at the common one. Have you used methyl red before? No. Let us. You've used it before. Where do you use it? In your school. Do you have methyl red in your school?
We have. No, use it.
It's methyl black that you have. So let's use the common one that we use. So we have methyl red though. We have so many indicators. We have alizarin yellow. We have promoter blue red. But the common one, you have the methyl orange and the phenolphthalein. Methyl orange. So let us look at acid, medium, look at alkaline, medium, and let's look at neutral, medium. Now, what will be the color of methyl orange in acid medium? It is red. Most are the pink. It depends on the concentration of the solution. So let's say pink. Now, what is the color of meteorite in alkaline medium? Yellow. This one we've done it when we did acid-base titration. That was why when the solution being given to use was pipetted and you added meteorite, the color was what? Because the color of meteorite in a base is what? Yellow. But what happened at the end point? What was the color that you observed? Orange. That means at neutral, the color of meteorite is supposed to be what? Orange. So this is what? Orange. But majority of you, instead of you having orange, what do you have?
Pink.
You have pink. Because you have overshot your titration. That means that solution, instead of it to become neutral, it has become what? Acidic. Because that means you had what? Too much acid in that solution. And that is why as you are adding more acid, you are moving towards zero. So your titration should be stopped. Immediately you have what? Orange color. Now phenolphthalein. Now what is the color of phenolphthalein in acidic medium? Colorless. So we have colorless. What is color in alkaline medium?
Pink.
It is pink. Who's that? Purple. What is color in neutral?
Colorless.
That means you cannot use phenolphthalein to distinguish between the solution of acid and a neutral solution. So we have colorless. So it is that means if three different solutions, suppose you are given three different solutions in a beaker, and you have to identify A, B, C is the beaker. The beaker was labeled ABC and contains acid, base, and water, but not necessarily in that order. How will you identify the content of each of the beaker? Litmus paper. Yes, you can also use litmus paper. If you use litmus paper, what happens?
Acid with
Because A, B, C contain acid, contain ACl, sodium hydroxide, and water, but not necessarily in that order. How will you identify the content of each beaker? What will you do to identify the content of each beaker? If you want to talk, you talk. Not that you say one of them. Yes. Yes. Add. Yes. You add an indicator. That indicator has no name. Now, the question is this. You were given beakers A, B, C, D, which contain ACl, sodium hydroxide, and water, but not necessarily in that order. What will you do to identify the content of each beaker? Speak as if you want to carry out the experiment on your own. Tell us.
Okay, you add meteorite in one of them.
You are the one doing it. You will use which one is you.
Okay, add meteorite in one of them, and if it turns pink, that means it is acid. Acidic medium. It is an acid medium. And if it's turns yellow, that means it is alkaline. And if it doesn't react,
I'm not satisfied with your answer. Who want to explain as if you understand what I've explained today? Who want to try? I don't condemn your explanation, but I'm not satisfied. Let me give the question again. Maybe because A, B, C is given containing ACl, sodium hydroxide, and water, but not necessarily in that order. Give one chemical test. Give one chemical test to identify the content of each beaker. Yes?
add about 2 centimeters of
methyl orange in each of the beaker.
Yes.
If the solution in the beaker changes from turns pink,
Yes.
the content of the beaker is an acid. You don't mention the acid. So the content of the beaker.
I've told you the name of the acid.
HCl.
HCl, sodium hydroxide, and water.
The content of the beaker is HCl.
Yes.
If it turns yellow, the content of the beaker is sodium hydroxide.
Yes.
And if it remains orange, changes to orange, the content of this beaker is water.
Please clap for it. As simple as that. The three solutions I mentioned, they are what? They are both colorless. They are colorless solution. Add to each beaker, add methyl orange. The beaker that form pink is what? HCl. The one that shows what? Yellow is what? Sodium hydroxide. And the one that form orange will be what? Water. In this case, you cannot use phenolphthalein because you can only identify what? Sodium hydroxide, which will give what? Pink color. Because both HCl and water will still give colorless solution. Wait, in that case, you cannot know which one is water, which one is HCl. Yes. What you did was called. It depends on the preparation of what your teacher gives to you. Supposed to be what? Pink. Is that okay? So when you further dilute the phenolphthalein and you now add it to it, it will give you a pink color, not a purple. And at any rate, if what you have originally is purple, by the time the thing turns to at that point, what you are going to get is what? Colorless. So it depends on the preparation that was made. It's most time when you add your methyl orange to, that's why I say it depends on the concentration of the solution given to you. Most time when you add the methyl orange to your acid, with your high concentration, instead of you having pink, it will be turned to red. Now let's move on to the calculation then. We move on to let's calculate. Question number 1 now. Calculate the pH of a 0.0001 mole per dl HCl. So calculate the pH of a 0.0001 mole per dl HCl. Now the solution given to us now is an acid. You get it? And this is a monobasic acid. It means this when you see mole per dl, it represents what? Concentration. Automatically what you are given is concentration of hydrogen ion. And we are looking for the pH. Which of these formula here is appropriate for this calculation? Question. That is number 1. So you can say pH of the solution is equal to minus log hydrogen ion concentration. And this is minus log. The hydrogen ion concentration given to us is 0.0001. This will give us what is log 0.0001? Minus 4. So the pH of the solution is equal to, is it difficult? It is difficult. I don't know why you are not talking. If you are hungry, that means you are not supposed to be in this class. This class is for things I want to learn, not for somebody I want to eat. You are not done. A sample of orange juice is found to have a pH of 3.80. A sample of orange juice is found to have a pH of 3.80. What is the concentration of the hydroxide ion? What is the concentration of the hydroxide ion in the juice? What is the concentration of the hydroxide ion in the juice? Now, when you are doing a question like this, you have to be very careful with the calculation. What is given is pH. Is that clear? Hold on, stop what you are doing and look up. I'll give you the question you solve on your own. Understand the concept. Once you understand the concept, you can use it to do all other calculations. The question gave us the pH, and we have to calculate what?
Concentration of
Hydroxide ion concentration. It means for you to calculate hydroxide ion concentration, you must know the pOH. So what we do is now is to change the pH we are given to pOH. So we first of all use this calculation, this formula here, because this is what that has the pH, the pOH. Now we are going to use that formula there to determine the pOH of that solution. So that will give us, you can say the pH plus the pOH is equal to 14. The pH is known. So we have 3.80 plus pOH is equal to 14. Then the pOH of the solution will be equal to 14 minus 3.80. And the answer is 10.20. Now, this is the pOH. We can now use this pOH now to determine the hydroxyl ion concentration. Now, if you use this solution, or you can use this solution, I mean this formula, this formula, determine the hydroxyl ion, because each of these one contain hydroxyl ion concentration. Which one do we use? So let us use this. So we have the pOH of a solution is equal to log 1 over hydroxide ion concentration. All we need to do now is to substitute to the formula. How do you substitute into the formula? The pOH is known, that is 10.2 is equal to log 1 over hydroxide ion concentration. Take the log to this side. It becomes what? Antilog. So that means you have 10 raised to power 10.2. And you say to say antilog. So 10 raised to power 10.2 will give us 1 over hydroxide ion concentration. And what is value of 10 raised to power 10.2? What is 10 raised to power 10.2?
1.585.
1 point.
585.
Are you sure?
10
10 raised to power 10. 10 raised to power 10.2 will give you
1.585.
1 point. So now let me get what
1.5585.
1.585 times 10 to the power 10 is equal to 1 over hydroxide ion concentration. Therefore, hydroxide ion concentration will go to give us what? 1 over 1.585 times 10 to the power 2 times 10 to the power 10. What will value is 6 point what?
31
times
minus 11.
minus 11. And what will be the unit?
Mope per diem.
Mope per diem. Mope per. So that is the hydroxide ion concentration of the solution. Use the second And use it or try the second formula on your own. You are not going to get it. You don't get it. Have you tried it? What she said is that instead of using this one, we should use this. We are using that. Let's see what we get now.
Same as
That means you are not good at mathematics. You should be able to get it. If you are not good at mathematics, this will give you problems because of the negative that you already have here. And that was why I used this. Hello girl, do you understand this one? The one I used. And you don't understand how to use the first one. Use the second one. Now let's look at the answer. I'll give another example before I ask you to do the last one. Number 3. The hydroxide ion concentration. The hydroxide ion concentration in a solution of sodium hydroxide of pH 10 is the hydroxide ion concentration of a solution of sodium hydroxide of pH 10 is, that is, what is the hydroxide ion concentration of a solution of sodium hydroxide whose pH is 10? What we are given? I hope you've written this one.
Yes, sir, please.
I don't want to clean the formula. That is why. Yes. What are the information given from that question? The solution we are talking about is what? Sodium hydroxide. What we are given is what? pH, IB, which is what? 10. What I have to calculate?
concentration of
Hydroxide ion concentration, IB. For us to get hydroxide ion concentration, we must know what? The pOH. That means we have the pH of the solution plus the pOH is equal to 14. That means the pOH of the solution is equal to be 14 minus 10. And that will give us what? That will give us 4. So we can now use, since the pOH is what we are looking for, we can use the pOH of the solution is equal to what? Log 1 over hydroxyl ion concentration. The substitute is just exactly the one we did. Which is 4 is equal to log 1 over hydroxyl ion concentration. Then from here, bring the log into the common log. That will be 10 raised to the power 4 is equal to 1 over hydroxyl ion concentration. What will this one give us? So hydroxyl ion concentration will now be equal to what? 1 over, and this is equal to 1 raised to the power minus 4. That is mole per
PM.
I hope there will be no problem with that.
Clear.
So you do this one for me as class 1. Question 1. Calculate the pH. Calculate the pH of a 0.05 mole per dm cube solution of tetraoxosulfate 6 acid. 0.005 mole per dm cube tetraoxosulfate 6 acid. Number 2. What is the pH of a 0.04 mole per dm cube NaOH solution? What is the pH of a 0.0400 mole per dm cube NaOH solution? The number 3. I said 0. First one 0.005 mole per dm cube tetraoxosulfate 6 acid. Now, what is the pH of a 0.00145 mole per dm cube KOH? How many questions is that?
3.
So let's have one more. Number 5.
3.
Number 4. Sorry, number 4. So what is the hydroxide ion concentration? What is the hydroxide ion concentration of a solution whose pH is 8.4? Whose pH is 8.4? Number 1. Please read the question.
Calculate the
Calculate the pH of
0.005 mole per dm.
0.0005, have we?
Yes, sir.
Mope by DNQ.
Solution
Solution of what?
Solution of
H2SO4. I check what majority of you did. Not get it. The one I gave you were all monobasic acid. This is the dibasic acid. You know what we are getting from these solutions is hydrogen ion. So if this solution dissociates, we have H2SO4. When it dissociates, we are going to have 2 hydrogen ion. In the solution we have here, the number of hydrogen ion or hydrogen ion concentration here is going to be 2 times 0.005 because there are 2 hydrogen ion that will be produced when it dissociates. So therefore, that hydrogen ion concentration is going to be, what is 2 times 0.001? 0.01 mole per dm. Then you can now see the pH of the solution is equal to minus log hydrogen ion concentration. This is minus 0.01. And that is what?
2.
This is 2. You know, this is minus 2. Okay, this is going to be minus. We have log 0.01. This is minus 2. Then the pH will be equal to 2. How many of you got that right? Just change it. So the next question, number 2. Read question 2.
What is the pH?
Of a 0.0
Of a 0.04
mole per dm cube NaOH in a solution.
NaOH. We are looking for what? pH. What we are given is what? Concentration of hydrogen ion. What do? We find the pH of the solution. Now, what is the most appropriate thing for us to do if we are to get it right? We first of all find the pH of this solution. They will not take it away from 14 to get the pH. Are we together?
Yes.
So we say the pH of the solution is equal to minus log hydroxyl ion concentration. This is minus log 0.04. What is log 0.04?
Minus 1.3.
Minus 1.339. 398. That means the pOH is going to be 1.398. Is that? What are we asked to calculate?
pH.
Therefore, the pH here is equal to 14 minus 1.398. And this will give us what? 12.60. How many of you got this one also right? That is important. Those of you that don't get it, no correction. The number 3. Number 3. Number 3. Great. Question 3.
What is the pH of a 0.00145 mole per dm cube? 0.00145
Mope by dm what?
kH.
pH.
kH.
What are we looking for?
pH.
pH. What do you get first?
pH.
Because what we are given is concentration of hydroxyl ion. So we have the pH of the solution will give us minus log hydroxyl concentration. That is minus 0.00145. So what is log 0.00145? Minus 2.83. This is minus 2.84. Then the pH of that solution will be equal to 2.84. Therefore, the pH will be what? 14 minus 2.84. 11.22. And the last one.
What is the hydroxide? Okay. What is it? Read it.
You cannot read it.
What is
What is the yes?
Whose pH?
8.4.
pH equal to what?
8.4.
8.4. So what do you need to get here? What do you need to get here first? What is pH? Then in pH you can get the hydroxyl concentration. The pH of the solution is going to be 14 minus 8.4. And that is 5.6. Then what do we use now? pOH is equal to minus log, there's a 1 over log hydroxyl concentration. What is the pH? 5.6 is equal to log 1 over hydroxyl concentration. So this is 10 to the power 5.6 is equal to 1 over hydroxyl concentration. What is 10 to the power 5.6?
398.
398
107.
107.17.
0.17.
This is equal to 1 over hydroxyl concentration. Therefore, hydroxyl concentration is going to be 1 over 39810.7. And the answer is what?
2.5 times
2.5 times power
minus 6.
minus 6 mole per
dm.
This is very so. Any question on the calculation? Any question on the calculation? So I believe by now, if you are given question on pH or pOH, you should calculate it correctly. Yes. Ask your question. Better you ask questions. Any question? No question. You have let me give you one more question because we have 8 minutes left. I wanted to continue. So do this one for me. Which of the following solutions? Which of the following solutions? Which of the following solutions has the lowest pH value? Which of the following solutions has the lowest pH value? Centimeter cube, that is 1. 5 centimeter cube of 10 mole per diem cube HCl. Two, 10 centimeter cube of 10 mole per diem cube HCl.
HCl again.
3, 5 centimeter cube of 5 mole per diem cube HCl. 3, so 4, 20 centimeter cube of 8 mole per diem cube HCl. Yes, which one of them has the lowest pH? The concentration for that one is going to be 10 divided by 5, which is what? 2. Are we together? What is no there? It means what I'm going to do that each of the following given to you, divide by the concentration you have there. That will give you the concentration. That will give you the new concentration of the solution. Divide each of the following given to you by the concentration. That will give you the concentration that you are going to use. That is going to give you the hydrogen ion concentration you are going to use to calculate your pH. For the second one, what's the volume given to us?
10.
10. Divided by what's the concentration? That is 1. That is going to be 1 mole per diem cube. Number 1 is 0. That means the second one go. If that one that has 0 is going to be that as well as going to be the lowest.
And that's
It's 5 by 5. That's one is equal 0. Then the one will go to the other one. 20 and 8. That's going to be a problem with that one. Let us cancel that. Minus 0. Let's do that one. So I will check what is wrong with that thing. They will do it in the next class. So when we meet next class, we are going to discuss salt. So you are expected to know the type of salt before the next class, so that the class is going to be interactive. So the type of salt, then how do we prepare soluble salt and insoluble salt. We are going to do some of the calculation there on water or crystallization. So till I come away again next class, enjoy yourself. Now.